All right, guys, welcome to second week. This is chapter 10, section 3. We're now doing experimental and theoretical probabilities. So we will be talking about how there are multiple probabilities. First one we're going to talk about, though, is experimental probability. So experimental probability is based on the results of experimental data. We are actually doing an experiment. We are not just talking about what happens if we spin the spinner. Do we land on this? What happens if we roll the die? No, now we're actually going to roll the die 50 times and we're going to see what our data looks like and find the probability based on that specific data. So experimental probability is a probability based on results of the experimental data. The formula that we will be using, remember, P event means probability of the event is the number of times the event occurs over the number of times the experiment is done. Think about it. If you roll a die 10 times and you land on the number 4 8 times, that means out of the 10 times you rolled 4 8 times, so you have an 8 out of 10 chance of getting a 4, right? You rolled it 10 times, you got it 8 times, so that's 8 out of 10. The event occurred 8 times, the total times the experiment is done is 10. Experimental probability can also be referred to as relative frequency. So I think you'll see that on a couple of the homework problems. Whenever you see relative frequency, make sure you just think of experimental probability. They are the exact same thing. When would this be useful? Well, you can use it for business. Businesses can use this for forecast, but also one really important thing is medical groups can study the effectiveness of medicines. For example, if you have a medicine and the probability says it works 99% of the time, great, that sounds pretty good, right? But what if they actually do the experiment, they give it out to 100 people and it only works 50 times? Then the probability means it works 50 out of 100 times, only 50%. So medical groups use this for medicine all the time. When they have some medicine that they want to test before putting it out on the market, they actually give it to people who might need it and see if it works. If it works almost every time, you know it's an awesome medicine. But if it doesn't work very often, it's not a good medicine. Even if it says it's supposed to work, you need to check to actually make sure that it works. All right, let's do an example of that. A medical study tests a new medicine on 350 participants. It is effective for 301 participants. Find the experimental probability that the medicine is effective. So remember, this is an experimental probability because the experiment was done 350 times, right? So probability of an event is the number of times the event occurs over the number of time the experiment is done. Therefore, the number of times the experiment occurred, 301. It is effective for 301 participants. Right? So it occurred 301 times. But how many times was the experiment actually done? It was actually done 350 times. So therefore, the probability that this is effective is 301 out of 350. You could simplify that. I'm not sure if that one could be simplified, but if we put that as a decimal, it's 0.86, or a percent is 86%. So that means this medicine is 86% effective. That's pretty good. I would take my chances on medicine that it will work 86% of the time. You guys like that number, right? 86. If you got a 86% on a test, you would probably like that, right? So 86% is pretty good. All right. You could also use it to predict the future. Not always exactly, because you can't actually predict the future, but you use it in weather a lot to predict what weather will look like. Suppose it rains 2 out of the last 12 days in March. If the trend continues, how many rainy days do you expect in April? Well, first we need to find the experimental probability. The probability that it will rain, let's look at the 2 out of 12 days. It rained 2 out of the 12 days, so that means 2 days it did rain. 12 was the total number of days. So if it rained 2 out of 12 days, that's the same thing as raining 1 out of 6 days, right? So now it rains once every 6 days. But how many total days are there in April? There's 30, right? So if we want to find the number of times the event occurs by multiplying the probability, how you want to find the number of times the event occurs, you multiply the probability to the new possible outcomes. So it rains once every 6 days, but there are 30 days, right? So if it rains once every 6 days, it rains twice every 12 days, 3 times every 18 days, 4 times every 20 days, and so on. Or you could do 1/6 times 30. Well, 1 over 6 times 30 is 5. And remember, we got the number 30 because there's 30 days in April. So each day has a 1/6 chance of raining. So 1/6 chance times the 30 days is 5. So you expect 5 days. All right, I'm moving on. You can pause the video to get that information. Let's look at theoretical. You already know what theoretical probability is. That's the good part about theoretical probability. You are not actually doing the experiment. You are just looking at what the probability should be. For example, rolling a 1 on a die is a 1 in 6 chance. There's 6 chances, or there's 6 different possibilities, but you only want that one. So 1 out of 6. Theoretical probability is looking at how likely an outcome is to happen. It's the same as we learned in practice in 10.2, so nothing new, right? Favorable outcomes over possible outcomes. So let's quickly review what the difference between experimental and theoretical probability is. Experimental probability uses previous results to kind of look like what could happen in the future, or using those previous results that actually happened. Whereas theoretical uses favorable outcomes, what should happen. So experimental probability uses actual results, but theoretical probability is what should happen. It should be this. They're not always going to be the same. All right, let's do an example. This one's a little bit tricky. The theoretical probability of winning a bobblehead when spinning a prize wheel is 1 over 6. The wheel has 3 bobblehead sections. How many sections are on the wheel? Think about it. This is theoretical probability because we're not actually spinning the spinner a bunch of times. We're not doing the prize wheel a bunch of times. We're just thinking what it should be. So the probability of winning the bobblehead is the number of bobblehead sections over the number of total sections, right? Favorable over possible. So this is what it turns into. Think about it. The probability of the bobblehead, it says 1/6. Theoretical probability of winning a bobblehead is 1/6. So probability of bobblehead is 1/6. How many bobblehead sections are there? 3. So instead of number of bobblehead sections, you write 3. How many total sections are on the wheel? We don't know. That's what we need to figure out. We now have a proportion. 1 over 6 equals 3 over s. So how do you get from 1 to 3? You multiply by 3. So 6 times 3 is 18. So therefore, s equals 18. You could use the cross products property, or you could multiply across. Think about the number multiplying across. There's 18 sections on the wheel. We know that's correct because 3 bobblehead sections over 18, 3 divided by 18 simplifies to 1 over 6. Since it simplifies to 1 over 6, we know that's the right answer because 1/6 is the probability. All right, normally we would be done. However, I want to do this one last example with you guys. This is one of your homework problems, so make sure you're paying attention. A lot of people get confused with this. What is the probability of spinning a 6? So on this spinner, you can spin a 1, a 2, a 3, a 4, a 5, or a 6, right? Now this is considered experimental probability because you actually spun the spinner a bunch of times. So let's look at this. How many times did you spin a 1? It says number spun 1. And how many times did you spin it? 8. I'm going to put in 8. How many times was 2 spun? 6. How many times was 3 spun? 9. How many times was 4 spun? 11. How many times was 5 spun? 9. And how many times was the number 6 spun? 7. So what is the total number of spins? So total number of spins. Think about it. You rolled 1, 8 times 2, 6 times 3, 9 times 4, 11 times 5, 9 times 6, 7 times. You need to add those all together. So 8 plus 6 plus 9 plus 11 plus 9 plus 7. Well, 8 plus 6 is 14, right? 14 plus 20 is 34, 43, 50 times. The total number of spins, 50. That's really important. but we just want the probability of spinning a 6. So we need to find out the times spun, oops, not sup, times spun 6. Well, how many times did we spin a 6? Look right here. We spun a 6 7 times. So therefore, the probability of spinning a 6, remember, it's going to be the number of times the event occurs over the number of times the event was done. So that is 7 times we spun a 6 over 50. Here, let me write that differently. I'll first write it down like this. Times spun 6 total spins. Keep spelling that wrong. Total spins. Therefore, the times we spun a 6, there are 7 times that we spun a 6. How many times did we spin total? 50. Therefore, 7 over 50, which equals 0.14, which equals a 14% chance. Right? 7 divided by 50 is 0.14, so you have a 14% chance. All of these are correct, a fraction, a decimal, and a percent, depending on how your answers look. All right, and that's pretty much the homework for tonight, guys. So let's look. Homework is due Friday, May 1st. Crazy, Friday is already going to be May. It's due at 11:59 p.m. Big Ideas, chapter 10.3. Only 15 problems, number 6 through 20. So if you want to use the textbook, that's fine. Remember, just send me a picture. It's pages 417 through 419. I actually think it's only page 418. But anyways, go to page 417, do number 6 through 20. All right, challengers. Hope you guys enjoyed this lesson. Didn't seem like it was too bad, but you never can tell. So I will see you guys later, challengers. Bye.